video project will be on the counting sort. So sorting type. The counting sort is unique from others because it sorts a list based off of the frequency of each element on the list, and the list will be in a certain range, which will be denoted as K. It is not a comparison-based sorting algorithm like most of the ones that we learn. It is more similar to radix. It's a non-comparison based sorting. How can it be used? It can only be used with positive integers, and it works best with a smaller list with a lot of frequently repeated integers. It cannot be negative, and it cannot be decimals, strings, etc. The runtime analysis. So the runtime analysis is O n plus k in parentheses, where n will be the number of elements in the input array, and k is the range of the integers in the array. So say if the range is 0 to 9, k will be 10. It's both the best and worst time complexities, O n plus k, because the steps taken in this sorting is fixed. It's not variable depending on how many elements are on the list, etc. It'll always be the same time complexity. So a little explanation of how it works. This sorting technique, it'll make a new array of the size of the range of elements based on the input array. So you have the input array, and then you'll get a range of all the different elements that could be in there. And then you make that array, and that's called the count array. And then you'll take the input array and calculate the frequency of each element. And then you'll fill in the frequency in the count array. And then you take the combined sum of each element. So the sum will be like 1 at position 1 and 2. You'll add it, and you'll keep going on, and you keep adding it. So this is kind of like hashing in the way that you're using an arithmetic sequence to carry it out. And this is why it's not a comparison sorting technique, because you're using math to translate it to a new array. So then once you do that, you'll assign each element to the proper position of the output array. So by doing the mathematics and taking the combined sum of the frequencies, you will get your new array. So I will show you all this in an example. For this example, I'll be using an array of type integers of size 8. As you can see, the range of the numbers will be from 0 to 9. So that means there won't be any negative numbers, and there won't be any numbers greater than 9 in the array. There's a completed input array, so you could see it's of size 8, and the indexes go from 0 to 7, and those are the integers unsorted. Next, we need to create a count array of size range and initialize all the values to 0. So since our range is from 0 to 9, the count array size will be 10. Up next, we'll iterate through the input array and place the tally in the count array at the correct spot. So at the input array, we will start with 2, and then we'll go to the count array, find number 2, and put a 1 there. So this will get a 1. We'll move in the input array to number 6. Therefore, we put a 1 at index 6, 2. So we go back to the count array, go to spot 2, and we iterate that by 1, making it 2. We go back to the input array, we see number 5, so we iterate place 5. 8, same thing, iterate spot 8. 3, go to 3 here, make that 1. 5, go back to 5, make that 2, and last but not least 7. And then we'll be at the end of this array, meaning we don't have to come back to count array right now. So just to recap that, every time you go through a value in the input array, you need to increment that index in the count array. Now that we're done, we have a count of each element. Now we'll have to modify the count array by cumulatively adding the previous count. This is where the math comes into our function. So this will always be 0. we go to index 1 and you add 0 plus index 1, meaning you keep that at 0. We move over to index 2, so you take index 1 plus index 2, making it 2 plus 0 is 2. And then you move on. Index 3 will be 2 plus 1, 3. Oops. Okay. This will be 3 plus 0, making it 3 as well. And then here you do 3 plus 2, making it 5. 5 plus 1, 6 plus 1, 7. 7 plus 1, 8. And then 8 plus 0, another 8. And then we're kicked out of the count array because we got to the end of it. These new values in the count array will serve as positions in the output array. So now we construct an output array that has the same size as our input array, which will be 8. And then just to make it easier, we label all the positions because that's what we will be taking from the count array. So we go to the count array, and 0 and 1 have values of 0, meaning that they will not make it to the output array. And then we'll move on to index 2. 2 has a value, and since it's 2, that means it'll take up positions 1 and 2. So we're gonna put a 2 and a 2. So those are done. We move on to index 3 in the count array. And since it's a 3, that means that 3 will take position 3. Okay. We move on to index 4. And since index 4 also has the value 3, but 3 is used, that means that 4 will not be in our array. So we cross that off. We move on to 5. And 5 will occupy up to 5. So that means we'll fill in 4 with 5 and 5 with 5. We move on to index 6, and this means that it'll occupy position 6, and so on with 7 and 8. So here we have 6, 7, and 8. And then, so we move on to index 9 in the count array, and this also has a value of 8, but 8 is taken. So 9 will not go in this array, but we've also filled up both of our arrays, so that's when it will kick out and be done. As you can see, this is a very interesting sorting method, and I hope you learned a lot from my video.